Let's rank metals from the most reactive to the least reactive. For this, we will have to do certain experiments, and in this video, we are going to react metals with water. Now, depending on how vigorously each metal reacts, we will list them in this particular series. You might recall that in a previous video, we attempted at something similar. We reacted metals with oxygen, and depending on how vigorously they reacted, we arrived at this particular list. Here sodium and potassium was most reactive, and gold and silver, they were the least reactive. But there was a problem with this list. See, over here at rank 3, you can find these 4 metals being grouped together. We weren't able to sub-rank them. So our hope with this new experiment is that we will arrive at a more detailed list, more well-organized list. So let's begin. So generally, metals when they react with water, they displace the hydrogen from water and form metal oxides. So here in this case, our products are going to be metal oxide plus hydrogen gas being evolved out. Now we also spoke about some metal oxide being soluble in water. This means that if this metal oxide is soluble, it will react with water to form metal hydroxide. So either our products are metal hydroxide plus hydrogen gas or a suspension of metal oxide in water plus hydrogen gas. So okay, with this, let's look at some examples. So first, let's react sodium with water. So sodium will displace hydrogen. That means hydrogen gas will be given out, definitely. And then sodium will react with oxygen to form sodium oxide, Na2O. Now sodium oxide is very much soluble in water. So this will react with water to form sodium hydroxide. Let me replace this. Sodium hydroxide. So these will be our products. Now along with this, in the reaction, you will also get a lot of heat energy being given out. Now let's look at the same thing in an actual reaction. So here I have a beaker of normal water or cold water, and I'm going to add sodium to it. And yes, sodium also reacts with cold water, even with cold water. Now you can see that as soon as sodium touches, it starts reacting. It starts to dance on the surface of the water. Now why this is happening is because as soon as sodium touches the water, reaction starts and hydrogen gas is given off. Now this hydrogen gas pushes the sodium into random direction, and that's why sodium appears to be dancing on the surface of water. Now along with this, we are also getting a lot of heat being evolved, and this heat is so much that it can even burn the hydrogen gas being released. So be very careful around this particular experiment. This can be very explosive, okay? Now you might notice one more thing. How quickly did sodium metal get finished off? And that's happening because sodium reacts very violently, very quickly with water and gets converted into sodium hydroxide, which is currently now dissolved in this water. Now how do we test this out? So see, sodium hydroxide is basic in nature. So if I add red litmus paper into it, you can see that color is changing to blue. Now this definitely proves that this solution is basic and it has sodium hydroxide mixed in it, right? So in this reaction we saw that sodium even reacts with cold water. It is so reactive that it even reacts with cold water, and it produces sodium hydroxide and hydrogen gas is released. And along with this, a lot of heat energy is given off, which can even burn this hydrogen gas. So be very careful. And potassium also reacts in a very similar fashion. It will also react with water to give potassium hydroxide and releasing hydrogen gas and a lot of heat. So these metals, they are our most reactive metals. They are rank 1 when it comes to reactivity series. Now let's look at one more example. So calcium, this also reacts even with cold water, just like sodium and potassium. So here in this case, calcium will displace hydrogen and will react with oxygen to form calcium oxide. So these will be our products. But calcium oxide, this is soluble in water. So this will react with the water to form calcium hydroxide, CaOH whole twice. And along with this, we will also get a lot of heat being released. And you can sense this because we started the reaction in a cold container of water, but you can sense it that the water container will start getting warmer. But let's compare the heat being released here with the heat being released in the case of sodium. So in this case, the heat was so much that it would even burn the hydrogen gas being escaping out, right? But here in the case of calcium, the heat is not sufficient to burn the hydrogen gas. It's lesser in comparison to sodium. And that's why we rank calcium as second in the reactivity series. So in the case of sodium and potassium, the heat would even burn the hydrogen, whereas in the case of calcium, the heat is not sufficient to burn the hydrogen gas. In fact, this hydrogen gas will start bubbling out of the water solution, and it will stick to calcium metal and make it float in water. You can check this out in the experiment in your lab. Now next we have magnesium metal, and this also reacts with water. But this cannot react with cold water. Cold water does not have sufficient energy for magnesium to react with it. So that's why we will need to heat the water. So magnesium reacts only with hot water. So this itself is an indication that magnesium is not as reactive as calcium. So we will rank magnesium as third in the list. So here also in this case, magnesium will displace hydrogen and react with oxygen to form magnesium oxide, and hydrogen gas will be given off. And magnesium oxide is soluble in water, so we will get magnesium hydroxide finally. Next we have aluminium reacting with water. In fact, aluminium, iron and zinc, they all react in a similar fashion with water, which is they do not react with cold or hot water, but they do react with steam, which is basically H2O in gaseous form. So this itself would tell us that all of these three are not as reactive as sodium, calcium or magnesium, and that's why I would rank them as fourth in our reactivity series. Okay, so in this reaction, aluminium will displace hydrogen and form aluminium oxide. And the different thing over here is that aluminium oxide is not soluble in water. So this is not going to react with water to give us aluminium hydroxide. No. And how I like to remember this is that aluminium is used as aluminium foil to wrap our hot food in our lunch boxes. Now hot food will give out steam, and that steam might react with aluminium to form some products. Now if this product would have been aluminium hydroxide, which is a base, that might have spoiled our food. So it's good that no base is being formed over here. That's how I like to remember how steam reacts with aluminium to give me aluminium oxide only. At last, we have metals such as copper, lead, gold and silver, and they all do not react at all with water. There will be no reaction, neither with cold water, hot water or steam. So okay, with this, let's rank our metals. So we saw that sodium and potassium, they even reacted with cold water, and the hydrogen gas that was being released was set on fire because of the immense amount of heat being released. At second, we had calcium, which also reacted with cold water, but there was no fire and the hydrogen gas was bubbling out. Thirdly, we have magnesium, which reacts only with hot water, not with cold water. At fourth place, we had aluminium, iron and zinc, which did not react with cold or hot water. They reacted only with steam. And at last, we had copper, lead, gold and silver, which showed no reaction at all. Now, with this new information, let's go back and update our ranking of the metals. So this was the old ranking that we had when we reacted metals with oxygen. Now let's compare and see what's new. So here still sodium and potassium is at number 1, but we have calcium coming in at number 2 and magnesium at number 3. That means we will need to include calcium in between here. Let's update that. And then we have aluminium, iron and zinc at number 4, and we came to know that copper and lead are less reactive than aluminum, iron, and zinc. So over here, we can update this particular rank and we can degrade copper to a lower rank. So something like this. And we already knew that gold and silver, they are the least reactive. So this is our updated ranking of our metals after these two reactions. But see, this list is still not very detailed. You can still see that at this rank we have 3 metals occupying the same position. Whereas over here, we still do not know which one is more reactive between copper and lead. So in future videos, we will do more reactions and we will try to detail this particular list. But for now, let's summarize the video. In this video, we saw that when metals react with water, they form metal oxide and hydrogen gas is released. Now, if the metal oxide is soluble in water, we will get metal hydroxide. And we saw that how different metals, they react with water. And depending on these, we updated our ranking of metals.